This here is.
Okay. Did I share that one properly?
Yes.
Okay. Connectors. We talked about them a little bit. The most popular that we use is called a PL259. It's the male version of the connector. The female is called an SO239. Those are kind of short for plug for PL259 and socket for 239. They call them UHF connectors, but it's really a VHF connector. They're good up to about 300 megahertz.
Didn't acknowledge any of my texts.
Who?
Nothing. I was simply texting you, telling you what was going on.
Talking to somebody else.
You didn't even look at your phone. Okay.
Bill.
Hey Bill, you're not muted.
Now.
Okay. A lot of times we'll use bayonet type connectors, which is referred to as a BNC. They're normally used on cables to connect up things like test instruments. A lot of times on the QRP type equipment, which is lower power, they'll use BNC connectors. You'll see it on oscilloscopes and signal generators and things like that.
A little handheld scanner with the BNC antenna.
And they're pretty good connectors. They're not waterproof. Okay, it's basically an internal.
Take on and off, and
yeah, it's real easy to do. Sometimes a PL259, if it's screwed on tight, you need a wrench to unscrew it. Then we have SMA connectors, which are very small, about a 1/4 inch in diameter. It's a small threaded connector. And they're used for very high frequency stuff with small coax for short runs. You'll actually see it if you were to take a modern radio transceiver apart. You'll actually see interconnections inside the radio done with SMA connectors and very short little coaxial cable runs. The type N connector we talked about is the best for UHF and up until you get to where you have to use waveguide type stuff. They claim they're water resistant. They do have kind of a seal. I guess that's kind of true. But you still have the possibility of water getting in around the crimp, just like a PL259. So you still have to wrap it with tape to cover it.
I use what's called shrink tape.
Yeah.
You guys use that?
Yeah.
Okay.
And the best way is actually multiple layers. You put a layer of I use the Scotch, I can't remember if it's 7/7 or 33, one of those. And it's a stretchy one like that. It's a plastic tape. You put that on over the connector, and then you put the rubberized stuff, and then put another coat of tape on top of that, because the rubberized stuff is not UV. So you got to protect it from UV with another layer of tape. But the first one keeps the rubber from sticking to the connector. So when you peel it off, it comes off. If you just put the rubber type, it's messy because it kind of melts onto the connector.
Yes, I know that one. That happened to me.
And then the PL259 is what is used in most cases. Probably the main reason is it's a third of the price of a type N connector.
It's also easier to install.
Well, an N is really easy if money is no object.
Probably.
Yes. Times Microwave has a series of N connectors called their Easy.
Right.
And if you buy the tool, the special circumcision tool, or LMR 400, or the Easy connector, which is like $300, it's just a single, well, two ends. You do it one end and then you rotate it the other, and it peels the outer insulation off. And it's just a slam dunk to stick it in their end connector and crimp it. But it's very expensive tools. You need to be doing a lot of it.
Yeah, I was gonna say, if you have a business, you know, you're doing that for a living, it sounds
Right.
good. If I'm doing it once in
A
my,
one-off is,
I'm gonna go try to find,
Yeah.
rent one of those tools.
I have a friend that owns one, I borrow it.
Okay.
That's the best way to do it.
Yeah.
This is a picture of the ones we talked about. And the SMA, the little 1/4 inch, these are not exactly to scale, is good up into the multi-gigahertz range. And then comes the end connector. And I've never actually seen a TNC, which I think is another version, I've heard of them, another version of an N. An SMC is kind of a takeoff of the SMA. Don't see those often. This little MCX, I think, even though it's much bigger than they are in real life, is what you find inside of a cell phone and things like that to make attachments to the printed circuit board. They're little snap-on connectors. Very hard to put on. It's got to be perfectly straight.
Automotive industry. Like some.
There's your typical BNC, the bayonet. I'm not familiar with the SMB or the mini UHF. And then we have our PL259 down here in the bottom right. So it's a little over, well, usually they rate them up at around 300 megahertz.
I got a question on SMAs real quick.
Okay.
Because I bought 2 radios,
Okay.
and for whatever reason out there, these manufacturers, the 2 handhelds, they can't come up with a standard male, female for everyone.
Yeah.
One radio is male, the other radio is female, and I can't swap
Well,
antennas.
there's a thing called a reverse SMA, which a lot of them use for their antennas, which is why you see one threaded, okay, that screws in, and another one that's not.
Now, I got the regular male and female both threaded in the right direction, but the antenna, so I had to.
No. The male part of the connector in the reverse is threaded
Yeah, like the picture. you
with a
showed.
male thread. Okay. On the
Oh, I see what
outside,
you're saying,
it screws in.
okay,
Whereas a normal SMA
so there's another variation I haven't seen.
has internal thread screws on the outside of the
Well,
connector.
why can't these people just come up with a, hey,
Well,
everybody gather?
why can't they
let's make
standardize on a lot of
a
things?
Singing,
Now, I don't remember who said this first, but I first remember Greg Mackey putting it in one of his sound manuals. The wonderful thing about standards is that there's so many to choose from.
Yes. Okay. Which of the following is true of PL259 connectors?
I would say Charlie.
That sounds like a good
Sure.
choice. They're commonly used at HF and VHF. They don't work well at all on microwave. They're definitely not watertight, and they're not a bayonet. The only bayonet is the BNC that I'm aware of. There's probably others. Which of the following RF connector types is most suitable for frequencies above 400 megahertz?
I would go with that alpha. Is it?
400 megahertz. We're talking UHF and above, right? Remember, UHF starts at 300. 300 to 3000.
So, working backwards, DD25, it's a whole different animal,
right,
completely doesn't
Right.
belong on this here. The other one, that's a cable, so those two are out.
right.
Type N was a higher range, but I was still capable of doing the PL up to one king.
Yeah,
So
within.
PL 259, remember, was 300.
Yeah, PL 259. It's best up to 300.
oh, okay, so I missed that then. I guess I missed that on the chart because I thought it was up. It was.
But in the interest of
Oh,
manufacturing, so they don't have
I see.
two different
So the-
connectors on your dual band,
So the
everything
Alright.
goes,
Yeah.
yeah. Type in is best, but
Right.
everything you find is gonna be.
They sell the PL 259 as a VHF UHF connector, but it's not really a UHF connector.
so they're lying.
Well, it goes up to 300 megahertz. That's where UHF starts. So technically, they're not lying.
They're in a gray area.
Yeah. It's got a usable up to UHF. So it's the type N
I
is
just
what
got that
they're
wrong on the
looking for.
test. See? 'Cause- Go ahead.
Yeah, the
Why
key
are we
there
all
is
using the wrong cable then?
the
Oh,
key
wrong
there is the
connector.
400 megahertz.
Okay.
I'm getting a lot of emails. Okay. So is this our okay, connectors can be difficult to install properly. It does take a little practice. I'm going to try to show you how we do one. Hopefully, you can do it in a couple of minutes.
Put all the two boxes. We know.
It's a frequent cause of feed line failure because of it could help or could cause a high SWR. If you really mess up putting the connector on. I did that the other day. I got a 100-to-1 SWR. Had a short in it. You make sure that they're properly crimped or soldered. Most people today use crimped connectors. Soldering the braid on a coaxial connector, which are the older style, is kind of hard. It's very easy to overheat it and melt the dielectric, which is not a good thing. Crimped is so much easier, and from what I understand, it's actually a better connection because you got essentially the entire braid making physical contact. Where when you solder it, you've got like 4 little holes that you got to fit solder through.
Oh, you're right about that. You're right. There are pins, that little hole, and that's where you put solder.
Yeah. And you got to hope that it, gets through there and spreads out. So,
I haven't done that in a really long time.
but in order to crimp, you got to buy a crimping tool where all you need is a soldering iron.
They're not that expensive.
No.
They were in the 90s.
Loose connections will also kind of the opposite of a short give you a high SWR if it looks open.
Only pinching curmudgeons who work in electronic shop and have access to 7 professional grade case soldering stations, AKA this guy. I just take my cables to work, and at lunchtime I solder them instead of spending $100 on here for.
Yeah. Well, I tried soldering some, but crimping's a whole lot easier.
I usually use the method where your braid is compression contact. So when
those adapter ones that screw in.
No, you just if you buy the right size connectors, when you slide it on, you fold the braid back down over the jacket, and then when you slide it on, you've got
pressure contact or compression between the braid and the outer case, part of the connector. And then the only thing you have to solder on is the center conductor.
Right,
Goes through
right.
a hollow pin, and all you do is fill that hollow pin and solder the center connector.
In most cases, you still have to solder the center pin, except for the easy in connectors, which doesn't require soldering.
Right.
It actually slides, the center conductor slides into a center pin on the connector. You don't have to solder it.
Do you have to crimp the?
No.
pin?
It's really neat. That's why they're $20 a connector.
Yeah. Oh, and me, we always had to solder those pins on before you put the outer.
Right.
outer
And you
shell.
got to get the right length for it. And I, try it up, clip some off, try it, clip some off. Okay. What can cause erratic changes in SWR?
Loose connection.
Right. A loose connection can. A thunderstorm can't. Overmodulation can't. And an overload from a strong local station can't. Yeah, but not SWR. So SWR is the term we use for standing wave ratio, and it's proportional to the ratio of the impedances. So if I've got a 75 ohm antenna fed with a 50 ohm coax, my SWR is going to be 1.5.
I bought a tester, I bought a SWR tester. The
Yeah.
only way I can learn these things is touch it, so I bought one. It wasn't that, I mean, it was $55, I think.
Oh, that's
I went
good
dummy
price.
load. Let's put a dummy load on the end and I can hold
Okay.
it, and so then I understood it.
If your SWR is 1.5 or less, typically you can operate without doing any other matching. I mean, it's not perfect, but the reflected power is not that much. When you get up to 3 and above, most of the modern transceivers, if they have a built-in antenna tuner, and most of them do, will start backing off your transmit power when you get a SWR above 3. And you get much higher than that. I mean, it starts cutting the power down more and more because it's looking at reflected power coming back. So if you get too much of that, in the transistorized transceiver, it can wipe out your power transistors. And then you got to send it into the factory or get somebody like Dan to repair it for you.
What if you lost all the smoke and you can't get smoke?
Yeah, when you lose the smoke, you're SOL. So what is standing wave ratio? SWR.
Sounds good to me.
I'm gonna go with C.
The transmitter efficiency ratio? What is efficiency?
I mean, that was my first choice, but then I started thinking transmission line. Like the first half of that sentence, measure of how well the load is matched. But then
Right.
I would have said to your antenna, which is that where the transmission line is?
Well, the load is the antenna.
Oh, okay.
Your transmitter is the source.
Yeah, I don't understand the terminology.
Okay.
Yeah.
The load is the antenna. So
Okay.
if your antenna
I would've
is
said
not
antenna, not load, I would have picked that one.
right, your antenna is not 50 ohms and you got 50 ohm transmission line, you've got a mismatch. So you get a standing wave ratio. You get a reflection of the signal back 180 degrees out. Like what?
This Pac-Man mismatch.
So the answer is alpha a measure of how well a load is matched. Remember, the load is matched to the transmission line
Load the antenna,
or dummy load.
dummy load, which I just said, and I should have got that right.
What reading on an SWR meter indicates a perfect impedance match between the antenna and the feed line?
1-to-1, baby.
1-to-1.
50-50, same thing.
No, it's not.
It just hadn't been reduced. Mathematically it's the same.
What does an SWR reading of 4-to-1 indicate?
Impedance mismatch.
There you go.
Very good. A bad mismatch.
Means you have a good 300 ohm antenna. You need a transformer, 4-to-1 transformer.
Yeah, that's going to be a 200 ohm antenna
Oh, 200 ohm.
or thereabouts. It's approximation, but
Yep.
the ratio seems to work.
Yep.
The formula is actually something like 1 minus the reflection coefficient divided by 1 plus the reflection coefficient. But it turns out about the same as the ratio of the impedances. So the SWR is going to be low when you got a good match. Obviously, if you got 1-to-1, that's the best you're going to do. You'll never actually get 1-to-1.
You put a dummy load on, I found.
Yeah, it might say 1-to-1, but that's probably the closest you'd ever get.
It's fine to be 1-to-1. I mean, it's already. every
Yeah, but
time I
remember, you got a
tested it-
piece of coax, you got a couple connectors in there.
Yeah, I have adapters because.
You got some extra resistance,
The tester has the SO
239
yeah, and then I
or
gotta change
259,
that.
excuse me.
I gotta change that to SMA. So I got a little adapter.
Oh, okay, right. And those adapters aren't free.
No,
I mean, impedance wise,
right.
so, and loss. Okay, so when the SWR is low, the losses are low. When you actually have a standing wave or reflected wave coming back, okay, when you send it up the transmission line, one of the reasons you have losses is the length of the line. You actually get IR loss, resistance loss. So the longer it is, the more resistance loss you have. When you have a mismatch, you get part of the signal reflected back, and you get more loss as it comes back through that same length of cable. It may be reflected, depending on how much power is still there, again, and go back up, and you lose more. And all this is causing heating because it's I squared R loss. Back up to the antenna, it's going to do that until it's totally dissipated.
It's winter time, we'll take a little bit of heat.
Okay. So the mismatch can in fact create a lot of heating depending on how lossy your cable is. Now, if you had some perfect transmission line, had no loss, it wouldn't matter about your reflection.
Question,
Okay.
if you have a high SWR in your transmission line, what do you do? Do you trim it or what do you do? What's the solution?
Well, there's kind of two things you can do. The most common is you're going to use either the internal antenna tuner in your radio or an external one to try to match the radio to what it sees through the transmission line in order to essentially protect your radio. The preferable way would be to have an antenna tuner or matching device that you could control at the antenna. so that you can do the match at the antenna, so you don't have an reflected wave coming back down your transmission line. And they do sell remote antenna tuners, and I hate the word because it doesn't tune anything, that you can mount up with the antenna and remotely control it. They're what?
So basically,
$3-4.
you tune the antenna and the transmission line.
Well,
Or
you try.
I'm sorry. Basically, you match the antenna and the transmission line. Sorry.
Yeah, that's the intent. And, you know, the closer you can get your antenna to being 50 ohms, okay, then the less you have to do as far as matching. And like I said, if you take a half-wave dipole and you do it as an inverted V, depending on how high it is, you can get it to look like 50 ohms. So you'd have almost a perfect match. Assuming there aren't other things affecting it, and there probably are. But the mismatch means you're going to get less power actually radiated out of the antenna. And more of it's coming back, and it's going to get dissipated in heat in the transmission line. And this is kind of a diagram of showing the blue incoming wave, and then when it hits, and it works just like sound or optical, okay? When it hits a mismatch, it gets reflected back out of phase, like 180 degrees out of phase. And as that goes along, you'll have points where the two waves are actually in phase with one another, and parts where they're out of phase with one another. So you get much higher voltage, which is why we call it a standing wave. It appears like a third sine wave. It's the sum of the two. And it can get very high. I guess you get thousands of volts potentially.
I'm surprised just 5 watts into a mag loop like that, you get over 9,000 volts.
What is the benefit of a low signal to wave ratio?
Signal loss.
Reduced signal loss. It has nothing to do with TV interference, as far as I know. Of course, I guess a reflected wave may radiate a little more out of your transmission line. I don't know. What happens to power lost in a transmission line?
Converted to heat.
Right. I don't like the way they worded that, because power wasn't lost. It was converted. We don't ever get rid of energy. We just convert it from one thing to another. So we converted it to heat. It's still somewhere, that energy. Okay, so I think I mentioned before that most of the newer radios will actually reduce their output power when they sense a certain amount of reflected power coming back. It's usually around 3-to-1 SWR, and then they start cutting back on your transmit power. And it's just to protect the output transistors in the power amplifier. Why do most modern solid-state transceivers reduce output power as SWR increases above a certain level?
To protect the output amplifiers.
Okay. Sounds like a winner. To protect the output amplifier transistors. And we're assuming most modern transceivers are going to be transistorized. If you have an older one that has tubes, they aren't as affected by reflected power coming back. Transistors are much more susceptible. Because remember, output power tubes are operating in the thousands of volts already. When choosing an SWR meter, and you bought one, did you note this?
Yeah.
The frequency range that it's going to operate over?
I absolutely did.
The maximum power that you can use?
Yep. I made sure that it would operate in the ranges that I thought I might need, even though I don't have the radios yet.
Okay. And because if you use it outside the frequency or the power range,
Break it,
you're
right?
going to either break it or get erroneous readings. And it probably won't work when you get your power amplifier at 1,000 watts.
No, I couldn't afford. They tell them. I said, the one that I can afford was, I think it was 120 watts was the max.
Okay,
But I'm not gonna go above that anytime soon.
right. Well, that'll handle
I
most,
had lower ones, and I said, but I might go over that, then that's useless.
right. Most base station radios are 100 watts. And you're probably going to,
At HF.
at HF, yeah, probably going to be doing maybe less than that, depending on the mode.
If I watch, people at 25 or 50 watts, things like
Yeah,
that.
if you're just VHF, UHF, it's all about getting your antenna up in the air. For a long time, I would just check in with the walkie-talkie. I didn't do the Baofeng thing. This was before Baofeng out of Yaesu. But I had a roll-up J-pole made out of TV twin lead. And I would get it up in a pine tree. And during the net check-in, I would talk to one guy down in Belfort by the college. And I live in Cocoa by the college. But I had my antenna up in the tree. If I have 50 watts, I've got another antenna. And I can put 50 watts into it. But it's only like 8 feet off the ground. I can't do that same route doing 50 watts on the ground.
Yeah. With VHF and UHF, height is everything.
So when you talk to a satellite with your handheld walkie-talkie, that's 5 watts. So you're doing 350 miles or whatever it is with 5 watts of its line of sight. So if you're doing VHF, UHF, get your antenna up.
And if you want to do over the horizon, the higher the better also. Remember the formula? 1 over the square root of, no, square root of 2 times the square root of the height in feet. So if you had your antenna up 100 feet, that's going to be 10 times 1.4 or 14 miles. So if you had a friend who had his antenna 100 feet up, he could be 14 miles on the other side of the horizon. And you could get 28 miles between the two. In theory, plus or minus, because that over the horizon thing is not a guaranteed amount.
Night edge diffraction. The VHF will bend a little bit with night edge diffraction. And a lot of times I would carry my walkie-talkie with me to different schools. And over at not Audubon, what's the other over there, Stevens. I knew about how many feet I had to walk away from the building to get the knife edge refraction over the building to the repeater. But I got too close to the building. I wasn't going to hit the repeater. I'd get maybe 75 feet away from it.
Okay, so which of the following should be considered when selecting an accessory SWR meter?
When I picked mine,
Okay,
I only had frequency and power level. I didn't consider at all distance or modulation, although I can't say because I'm gonna just stick with A.
okay.
Cinnamon toast apples, apple.
The frequency and power level at which the
I don't- I
measurements
looked
will
at-
be
I
made,
didn't-
right?
I didn't see anything else that said about distance or anything in the
Well, it
choices.
doesn't really have anything to do with it.
Modulation.
Modulation shouldn't have anything to do with it. So, and all these are correct or not correct because we've got two wrong ones. Okay, so one of the ways you can measure SWR is what they call a directional watt meter. And that's what most of the SWR circuits really use. I have yet to figure out exactly how they work, but essentially you sense the power coming through the coax in both forward and reverse direction, and demodulate that signal, and that's what drives the meter. In a lot of cases, they use what is called a cross meter. It's actually two analog meters in the same little housing. So it has two needles, and one moves with forward power, one is reflected power, and it has a scale on it. And where those two needles cross, where that line is, will tell you what the SWR is. It's the ratio of the forward to reflected. In the more ones with the digital readout, okay, they're calculating that ratio and displaying it as a number usually.
That meter is an example of what he was talking about there.
They're a little harder to read.
Yeah, I don't have my reading glasses, distance glasses. I can't wear bifocals, but I need them. I can't see little with these glasses.
But the one thing you can't tell real easily, you see the needle for forward power going up. And if you see very little motion on reflected power, that's good. And the more the reflected power is moving, the worse it is. So you don't necessarily need to know what the actual ratio is. Now, most modern radios will have a built-in directional watt meter and show you SWR. Some cases, they'll show you forward and reflected power, but usually they'll have a way to display the SWR that they're seeing at the radio. Now, that tends to be, I know on mine, after the antenna tuner. So it's showing me after the antenna tuner matched the transmission line and antenna, what the SWR is. And in most cases, it'll be down 1 to 1. It can't always match it that well, so you'll sometimes see it. And if you bypass it, then you'll see what the actual is. The default is it's normally in the loop.
And most onboard tuners will do 3 to 1,
Yeah.
get it down to 1.2, 1.1.
And if you're over 3 to 1, you should look at fixing something.
Yeah.
Something's broken instead of trying to.
Well, you're not.
Tuning is what is a form of cheating, I guess. So you got
Well,
to fix it.
yeah.
Well, you're having it's telling you that you got a big loss in your antenna, chances are. That is unless your match is right at the antenna. If your matching unit is right at the antenna, you can force just about all of it out the antenna. But if your matching unit is near your radio, a lot of that loss is gonna heat up your coax.
The matching unit up on the antenna is the best way to go, but you know, it's another more expensive option.
Yeah.
Is,
So best thing is
is,
having,
Go ahead.
is having that matching unit in the transceiver a feature of only very expensive transceivers, or is it a fairly common feature now in transceivers?
I'd say, I don't, you know of any that don't?
I think most modern ones do. I've got the radio I have, I've got this Igneo G90. It's a 20-watt transceiver, and it's probably the least expensive HF transceiver available.
So if you video them,
Around $500 on Radioddity. I bought it on Amazon when they had their Prime Day. Well, actually, my wife bought it for me and surprised me with it. But when she bought it, it was $395, and it's got what it throughout the industry heralded as being the best internal antenna tuner built into a radio. I've heard people say that you could shove a banana in the coax connector jack and tune it in, or shove a banana into the jack and tune a banana. I've never tried it, and I never will. But I know that it will tune anything I put on it effortlessly.
I see a lot of videos, they seem to be very popular.
Yeah.
Well,
Well, it gives you more area. I mean, if you're, it's like that magnetic loop right there. The magnetic loop is a great antenna, and it's Byron told me that the magnetic loop is good for
40 through 15 that one is.
well, for noise.
So, yeah, for,
So if you're in a noisy
noise.
condition, yeah, it's electronic noise we're talking about.
yeah, if you've got local noise, like maybe your neighbor's plasma TV or air conditioner, it tends to pick up less noise. And then also right through the middle, like if there's an axle through the middle of the loop, you can point that at the noise source and get even more noise suppression. I used to put that in front of my condo and point it at the air conditioning. So,
But yeah, I mean, that antenna, I gotta do a little bit of work on it to get it up and running, but yeah, I forgot where I was going with that. What were we talking about?
noise and matching.
Yeah, matching.
Yeah.
It's a very good antenna, but when you get it tuned, you've got a very narrow region to work with.
Yeah.
But like this antenna right here, once you get this one tuned, you can essentially work the entire band. With that one, if you change frequencies by 50 kilohertz, you have to retune it.
Now, a little bit more than 50 kilohertz. I'm just putting it out. If you change a megahertz, you gotta retune it, you know.
But you know, this one right here, once you get it tuned, if you, what I always do with any of the wire antennas is I go to the center of the band, I tune it, you know, I press the auto tuner and tune it, and then I've got the entire band. So I don't have to.
And in most cases, your antenna isn't going to be broadband enough that you can get the entire amateur band and have it resonant or close to resonant. So depending on, like if you put it in the middle, you might get it matched up to 1-to-1 in the middle. You get out to the ends of the band and you might be up to 2-to-1, 1.5-to-1.
I tune the center of the band, and I'm talking like, you know.
Well, I'm talking more like a dipole.
Probably not the 10 meter, like, you know, 15, 17, 12, 20. Yeah. I tune it in the center and I'm generally good to go, but now the radio will tell me if I'm getting out. And on 28, if we're 10 meters, 28 megahertz, it will do that.
Now,
That's a wide band.
to a certain degree, the more broadband the antenna is, the less efficient.
Right.
To a certain degree.
Okay, so and we talked about the directional watt meter, and it uses the forward reflected power to calculate if it's one showing a digital value for SWR. They're actually doing that calculation. I got the formula wrong when I mentioned it before. It's 1 plus the square root of the ratio divided by 1 minus the square root of the ratios. If you plug in a 1-to-1 in there, you should get 1 plus 1 divided by, wait a minute, let's see,
Reflected power.
1 plus 0 divided by 1 minus 0. So you get a 1-to-1. If you got a perfect match with no reflection. Which instrument can be used to determine SWR?
Iambic pentameter.
Directional watt meter.
Oh,
I tried.
let's see.
So what is an iambic pentameter?
Poetry. As I recall.
I think you're right.
That's a long time ago. That's high school stuff.
Yeah. That's
So we can use a directional watt meter. We can't use a voltmeter. I was trying to think if theoretically there was a way you could do it.
that's
If you had a way to measure the two voltages, but I'm not sure how you'd do it. And I don't think you could do it with an ohm meter. So where should RF power meter be installed?
Between the transmitter and the antenna.
Right. Doesn't matter which end. Could be at the transmitter end, which is usually where you'd have it, but it could be at the antenna end, and then you have to run out to read it.
if you do the power supply out, but probably won't be a good day for your meter.
So you put it in the feed
Couldn't even
line
read the rest. I sure the first time I knew that was it.
between. Now that's bad. Read all the answers before you circle in
I
the.
knew that was it because I've done it on my table. I'm like, here's my radio, here's my antenna, I put it right in the middle. So I didn't have to go anywhere. It's like right there.
Okay.
And so I knew that was the answer.
But sometimes the first answer in the list might seem right, but it have like one word in it that makes it wrong. And you tend not to read the other ones. And, maybe the last one is the correct one. There's not many like that, but there's a few. Where in one word,
There's a few.
Make
that
the
I
difference.
was just there thinking like, could be this, could be that. I'm not 100% sure. The wording is a little weird to me.
okay, so
If you hear me give the answer, it's correct because I carefully, meticulously read everything. Just ask boss.
the antenna analyzer, okay, can also be used to measure SWR. Those are no longer laboratory instruments. Vector network analyzers used to be fairly expensive test equipment boxes. You can get portable ones. We have the Nano VNA for like $80. And then we have the, what's this, a rig blaster or rig runner?
Thanks, rig expert.
Rig expert, yeah. From the Ukraine.
Yeah,
They still make
totally from Ukraine. Who knows where it's going now?
and you can get one of those, which won't do as much as one of those. It's easier to use. This is about a $400 one. That's an $80 one. This is borrowed, not mine.
And the $80 one does more.
Yes, it will do Smith charts. It will do TDR.
But it comes from a Yongdang province.
Yeah, it is
Like all
Chinese.
electronics does.
So you can measure SWR with it and do it over a frequency range in both cases, and they'll actually show you a plot of what your SWR is versus frequency, so you can see where the dip is and where it's resonant. In some cases, you can measure capacitive and inductive reactance, like with the nano. In both cases, they're signal generators because that's how they work. They put out a signal and they look at how much of the signal is reflected back. So you can use it as a signal generator. Like I said, the nano VNA, and there's several versions of them, all based on the same original design, can do all kinds of other things besides just doing SWR. Here's a picture of a couple, the nano over here on the right-hand side, and it comes with some accessories for calibration and connecting it up to devices. You usually have to have some adapters to get it up to PL259 or SO239 connector. It has a rechargeable battery in it, and you charge it up with a USB-C cable. You can also connect it to your computer, and there's several software programs that work with it, and they will actually let you control it and do this display on your computer screen. So you don't have to work with this little, 2 or 3 inch screen.
Got a QST from KU0R. The weather service is doing a Skywarn class tomorrow, 12/1. So people want to, recertify. Tomorrow's the day.
Where?
Temptation.
Oh, okay. MK. Well, there you go. Of course, it wouldn't do you any good yet.
No,
Well, I don't know. He could get certified, couldn't he?
Yeah.
He didn't have to have a license.
I saw that they were giving classes. I thought about going in front of the head work.
On the left is the MFJ version of it. A lot of people use those, and it's got meters and a little digital display. It kind of works like the Rig Expert, only it's not quite as portable. It's a little clunkier box, but it's cheaper. I think these are what, $200 or something like that.
Yeah, I think they're 269, 259.
So which of the following is used to determine if an antenna is resonant at the desired operating frequency?
Cheap whiz box. So that is a choice, is it?
Yeah, we hadn't talked about a VTVM.
Yeah.
I still have one.
Virtual TV manufacturing.
No, vacuum tube voltmeter.
Oh,
Bravo.
Bravo? Bravo sounds good. The antenna analyzer. A vacuum tube voltmeter is just a voltmeter with a very high input impedance.
and you could use a antenna analyzer as a Q meter.
Yeah, some of them, like the Nano VNA, I don't know if you could do it with the Rig Expert. Right.
You'd have to do the calculation manually.
And the frequency counter, I don't see how that could do you any good. Okay, so if the antenna impedance is not 50 ohms, and in most cases it won't be, what you're going to see on the transmitter end of your 50 ohm transmission line is not going to be 50 ohms. It's going to reflect back whatever the impedance is at the antenna. And that's why you're doing the matching unit usually, the built-in antenna tuner or the external one at the transmitter end. But it's essentially to protect the transmitter. And the main thing there, is that impedance matching is what they do. They do not tune your antenna. You tune your antenna by changing the length of it or adding inductors or capacitive hats or something like that to affect the electrical length so that it's resonant at the frequency you want. And when it's resonant, you have no reactance components, so your SWR is going to be 1-to-1, only at that frequency. What is the major function of an antenna tuner or antenna coupler?
I'm gonna go with alpha.
All right.
Sounds reasonable. Let's see. How about that? It matches the antenna system's impedance to the transceiver's output impedance, which is normally 50 ohms. Okay. Now, one of the other things that you may find useful for troubleshooting and stuff is to be able to simulate your antenna with a perfect antenna called a dummy load. And the dummy load is a non-inductive 50, usually 50 ohm resistance that's capable of handling a certain amount of power for a certain amount of time. One like this MFJ 300 watt will handle 300 watts for a few seconds. It might handle 50 watts for 10 minutes. So, you know, it's just how much power it can dissipate. You can't
look at those things when I bought my little dummy load. It's a little like a looks like a heat sink,
yeah,
like
Yeah.
a cylinder heat sink.
yeah.
And all I looked at was that it was 50 ohms. That's it. I didn't look at how many watts I could pump through it.
It's probably 10, 5 or 10, probably.
I didn't look at that as a because it was
But
cheap. And I was
it's
like,
fine
oh,
for a like QRP setup where you're only going to be transmitting 5 or 10 watts.
I didn't think about it, so I didn't really match that with the SWR tester that I.
Now you can get them that go up to a kilowatt or more. Of course, they're more expensive. I think this MFJ one, which I think is the same one I have, I think it's a little over $100, something like that. There's the old Cantenna, which is a bunch of resistors in a gallon paint bucket filled with oil. And it can handle a kilowatt for a while. I'm not sure how long. You would need, you know, you don't need to worry about that until you get to the point where you buy a power amplifier. Which if you stay in the hobby and you get your general or extra license, and after a while, you'll probably want to get a power amplifier so that you can stomp on those people that are only running or that are running more power or better antenna than you.
Or in about 6 or 7 years from we're at the bottom of the solar cycle,
Yeah.
and you want to make your own opening.
Yeah. It helps break through pileups, right?
Yeah. It helps with propagations.
What's the primary purpose of a dummy load?
Alpha.
I was gonna blurt out alpha right away without
Yeah.
reading the other ones. And I read them anyways.
Okay, good. And it's still alpha.
It's,
Okay. So it allows you to transmit without actually being on the air so that you can test your equipment.
yeah, especially for unlicensed people like me.
Right. And hopefully you're going to see a 1-to-1 SWR when you do that.
Yeah,
If your dummy load is really 50 ohms and everything else is working right. So basically to prevent transmitting signals, what does a dummy load consist of?
Bravo.
I was gonna throw it out that before I read the rest. So
Yeah.
I've held it in my hand, so I know it's a heat sink.
Okay. Yeah, some kind of heat sink, whether it's oil or a metal fin heat sink. There's some active ones that actually have a fan, but most of them don't. So a non-inductive, and that's the key, it's got to be a non-inductive resistor. Because if it was like made out of wire wound resistors, which have inductance, you're going to have a reactive component in addition to the resistance. So it's not going to look like a 50 ohm impedance. Be 50 ohms plus J or minus J, well, in case this plus J something, because it's going to be a inductive reactance. So it's going to be a positive imaginary number. Okay, so we learned that connectors, we have PL259s are the most common, but they're only good to 300 megahertz. Type in, work up into the gigahertz range, and they have more moisture protection, but you need to cover all of them. SWR is just a measure of how well your load is matched back to your transmitter through the transmission line. A high SWR can be the result of loose connections or a short. It will also give you a very high SWR. 1-to-1 is the perfect SWR match, which you don't normally see in practice. You might get a 1.103 or 05 or something. The lower the SWR, the better the match, the less signal loss. The higher, the worse the match, and the more loss and heating you're going to get in the transmission line. And that most of the transmitters are going to start reducing power once you get over a 3-to-1 SWR ratio. We can measure SWR with directional watt meters or with antenna analyzers. We use what we call antenna tuners to match the transmitter to the load or the transmission line. And we use the dummy load, which is a non-inductive resistor on some kind of heat sink, so that we can transmit without actually transmitting on the air. So you can make sure everything seems to be working before you spit out a bunch of spurs and other things. When you transmit into the dummy load, you can hook up an oscilloscope or something like that to look at your signal and see what it looks like before you actually transmit. Any questions on those?